As we begin a brand new semester, what I want to just impress about everyone is think about what we're doing. You can memorize, but what you really have to do is apply. So if we talk about a solution formation, what we're really talking about is a solution in water that we symbolize by aqueous, and normally we have some sort of solid that we're putting into water. So normally it is an ionic solid, and it will form a cation and an anion. As we go deeper into this course, we will talk about the concept of equilibrium, and they call solubility a dynamic equilibrium. There are solid ions going out into solution as well as ions coming back to the solid, and we'll go into this as we go through this chapter. So there's one way to think about it in terms of the equation. There's a second way to think about it in terms of this beaker. And then there's a third way to think about it, more or less a real-life equation with sodium chloride. Our focus, when you think about solubility, it really is on the corner of the lattice. What is really happening? Well, the hydrogen of water is attracted to the anion, the delta negative, and the oxygen of the water is attracted to the cation, the delta positive. So again, a couple different ways to show you. Here we have the hydrated cation, here we have the hydrated anion. So chemistry in real life, like let's say I want to measure the caffeine content of a chocolate bar. Or how could you compare it to the caffeine in coffee? There is the chemical chemical structure for caffeine, and it's definitely not a 3-hour lab. When you're trying to do something in the real world, often there's a literature search. You have to figure out a representative sample. You have to figure out the preparation. You have to do the analysis and make sure you can replicate, and then you can draw conclusions. So we are not doing that. We are called Chemistry 1220, where we're talking about different concepts. So the other thing I wanted to point out is there are many variables when something dissolves. What actually dissolves when you make a cup of coffee or a cup of tea? Well, there they are. There's some coffee, there's some tea. Why do you need warm water? What is that nitrogen brew that we hear about, including for beer, okay? The other thing I want you to think about is you know from 1210 that ethanol is a liquid. But did you know you can also have it as a solid? Here's a little packet of powdered alcohol, and essentially it is sitting inside a larger structure. So essentially you could, can't come to lecture, but if you came to lecture, you could bring a bottle of water and put in some ethanol, all right? Properties of solutions. This chapter to me is very critical. The real world is all about things that dissolve. Think about your human body. We'll go through them one by one by one. But some terms. If I say the word solution, I mean it is not going to settle. Maybe when you were a little kid, you used to take muddy water and stir it up with stones, and you notice that those stones always stayed there. That was not a solution. Well, a homogeneous mixture, by our definition, will be two or more substances. They could be ions or they could be molecules. And now that you've had 1210, you know what I'm talking about. Solutions are possible in every phase. Right now, you're breathing air, which is a solution of gases, liquids, solution of water, and if you have an alloy, that's a solid solution of different, often metals. So we've got point number 1, point number 2, and then there's point number 3. We're going to use the term miscible. That's where things mix in all proportions, and we'll talk about how you have similar forces to make things miscible. We can also describe things as immiscible. That's where they form multiple layers, kind of like Jell-O. You know, you can make them different layers, but it can be liquids, Italian salad dressing as it settles. And that's going to depend on polarity. Finally, 2 other sets of words. One of them is solvation. Solvation is when a solute interacts with solvent. Our class primarily deals with water as a solvent. It is hydration, and we symbolize it by aqueous. As an example, let's talk about a solution of sugar in water. You're probably thinking, oh yeah, water is the solvent, because that's present in the greatest quantity. Oh, what's the solute? Oh my gosh, that is sugar. But if you've ever made something for a hummingbird feeder, I always ask in class, and I will when we're doing the Zoom, what's the ratio? Well, normally it's 2 cups of sugar to every 1 cup of water. Based on our definition, our components have changed. The solvent is now sugar and the solute is now water. Again, some terminology to get us started.